Hello, everybody. Welcome to the first session for the OpenAI and Data Track. My name's Stephen Chin. I'm the VP of Developer Relations at Neo4j and also the content chair for the LF Foundation. And Ezequiel,
Easy, go by Easy. I'm an AI open source evangelist. I work at Intel. I'm also part of the Linux Foundation AI and Data. I'm the tech chair and also board member. So welcome everyone.
Yeah, and what we're going to chat today about is we're going to chat a bit about OPEA, which is a framework for building generative AI applications that lets you build with a neutral stack on Docker or Kubernetes. We're going to be chatting a bit about GraphRAG as well, which is an advanced technique for improving the accuracy, explainability, and transparency of your models. And we have a cool demo to finish it off. So it'll be a lot of fun.
A lot of fun. All right, a quick question at the beginning. How many of you are familiar or know what OPEA is? Cool, great. How many of you are familiar with GraphRAGs? Now, let's start with the beginning, RAGs. Okay, GraphRAGs? Okay, that's cool. All right, so this session will talk about that. So we will be starting presenting OPEA for those of you that don't know it. Not you, that you know it, so most of people. So why would we need something about related with OPEA or something like that? Mainly because if you are working with GenAI or if you are developing something, you may feel or you may know that GenAI is started to be complicated if you like to use it or to implement it. You have new things every day. It's a very dynamic environment. It's emerging rapidly. But it's not only for you as a developer, it's also challenging for enterprises. If you're an enterprise, you would like to buy something or use something that is mature, that you have the support, or the project is stable. So in that moment, you don't know where to go, actually, right? So the main goal, and that's why we are here, open source, open ecosystems, we like to use tools that can be usable with other tools. And they would like to use standards, would like to use things that, hey, I don't want to build something, and if I would like to change some of the components, I need to rebuild the entire application. I don't want to go there, and we don't want to go there. So the main idea is to rely those projects, GenAI deployments or applications, on something that can be easily replaceable or plug and play or adaptable. I used to use this slide because it talks about where we are now. So it's something really crazy. I will not go to all the details, but now we are talking about agents, we are talking about LLMs, graphs, GraphRAGs, and we haven't been working with that for the last 20 years or 30 years. That started probably in 2017, probably 6 years or 7 years. And we've seen this explosion of LLMs, platforms, ecosystems, models. You have a new model probably every day and most of the time, and platforms, right? So now we have, it's more to visualize all the options you have to choose when you are deploying something on GenAI. And you have these tons of Legos, right? So how too many options, you don't know how to decide it. There's something very important that I didn't mention, that is you end up reinventing the wheel, right? So you would like to build something, you don't know what is available, or probably you are overwhelmed for everything that is available, and you start inventing your own way to do things. So you start reinventing that. There are few best practices, so that's mainly the visualization that we see in the environment today. So for that, we have a platform that is a platform that solves you, or try to solve those problems, or to help you, which is Open Platform for Enterprise AI, OPEA. Is an open source platform project. It's part of the Linux Foundation. It was donated 1 year-ish ago. And what is important to mention is that it's open source platform project. So when we talk about a platform project, it's not that you do pip install and it works. You need to rely on a platform, right? So it's based on microservices, for example, or containers. So containers will run on Docker, Kubernetes. So you need to rely on that platform. And that's the project that will give you the composable building blocks for you if you like to deploy something related with GenAI. Could be RAGs, could be GraphRAGs, could be agents, could be code generation, and so on. So the main idea is to provide how all the end-to-end workflow or pipeline actually works. You don't need to pay attention on one particular thing. You will have a blueprint, for instance, that will give you the LLM, the vector database, the graph database, the prompt store, and everything, the UI, the Nginx. It's a project that is highly tied to something related with enterprise or to the enterprise development. You need to care about scalability. You need to care about security. Those kind of things, if you have a microservices architecture, that will help you to do those kind of more enterprise developments. There are some a part that is very important, which is the evals part. We can build those applications very easily, but if we don't have visualization, or if we don't have the evals part, we would like to know how those agents behave, or agents or applications behave. So there's another part of the project that particularly goes specifically on assessments or visualization. And as we mentioned, it's an open source project, so there are more than 50 or 60 partners contributing to this project. Each partner is contributing their part. I'm from Intel, Stephen is from Neo4j. We are just 2 companies between 50 or 60 companies, and each company is contributing their part to the project. Of course, Neo4j will be contributing the GraphRAG part, optimizations, and whatever, and Intel is contributing the optimizations on hardware. AMD is doing the same thing, NVIDIA, same for vector databases, for instance, MinIO, Redis, and also VMware, Red Hat, they're providing the way to deploy those applications. It's divided on 2 main components. I will not go too many details here, but it's actually, you have a blueprint, which is the end-to-end, a Docker Compose file or a Helm chart, and you have the component itself. For instance, in the case of Neo4j, I'll be using you as example. So Neo4j, and you have the RAG example, the GraphRAG example, when you have an LLM, when you have an embeddings model, right? You have those components. But you also have the component that talks about the GraphRAG. So all the things that are related with GraphRAG is a component that Neo4j contributed. And same for all the partners. They are all contributing in their part. So the main idea and the main analogy is you have those Legos block. So depending on what you would like to do, you pick the Legos that you would like, and you build your entire application, your blueprint. So the deployment options are mainly 2, as I mentioned, Docker Compose file and Kubernetes, depending on where you are. If you have a Kubernetes cluster in a more related with enterprises, you'll be using a Helm chart, or you have the Docker Compose file. This is the concept on how a RAG blueprint is built. You have everything divided by function. Every time we talk about cloud native, we talk about functions, right? So everything is isolated. You have an embeddings, which is a container or a microservice. You have a vector DB, you have a retriever, a re-ranking, an LLM, and these are all components, independent components, in your blueprint. And this is basically what you have in your blueprint. Of course, you can change the component, you can replace, you can add components there. These are API calls, right? And this is the RAG example. So what is a RAG example? RAG is when you have your LLM, every time you would like to make a question to your LLM, and I suppose that question is, you would like to know how is the weather today, let's say. And the weather is a simple example to use, right? The LLM will not know, of course. So in that case, you need to provide the context to this model somehow, so the model can give you an answer. If you have a PDF, or if you have a document, or your knowledge base, you would like to have a mechanism, which is the one that I showed before, so that can ingest the content to in a new prompt, and that prompt go to the LLM. It's like an explanation, a 2-second explanation, right? But that's basically, it's not as simple, but that's basically, it's very static. But I will go a bit more in details. So let's suppose you have a knowledge base, your own knowledge base, when you have all information about your customers, or about your, let's say, your customers. You would like to find a way to retrieve those documents, This is what these two microservices, the retriever and the embeddings and the vector database. You are actually retrieving the most similar documents to your question. You are augmenting, you are having a new prompt, which is basically a kind of prompt engineering, a way more advanced way of prompt engineering. So you are providing that context in the prompt, and that prompt is going to the LLM. And the LLM is making up an answer based on your prompt that you provide. And that prompt contains information that is most similar to your question. And suppose you would like to make a question about a customer or something that you have in a knowledge base. That similarity search is what will go to your vector database, will extract the most similar documents, and those documents will go to a new prompt. This is a 1,000-feet explanation, but this is great for some use cases, but sometimes, let's suppose you would like to make a question about how Python influenced other programming languages. In your knowledge base, you have Wikipedia links, you have Python descriptions, you have even a Python site. In that case, what will happen is this context will be stored in the knowledge base. The question will be the question that I mentioned before. Right? So what will be happening is the question will be converted to vectors. Those vectors will compare with all the vectors you have in your knowledge base, which is all the documents you have from your Wikipedia or in context. And this retrieval is actually doing similarity search, vector search, between your question and your knowledge base. Find them the most similar and give you a prompt. This new prompt go to the LLM, and the LLM will make that answer. But the answer here says that Python was created by Guido in 1991, is known for its readability, and so on. The answer is not wrong. The answer is correct. But the problem that we have is that we are missing the connection between those concepts. The answer that we would like to have is the same question, how has Python influenced it? We would like to know how it's related with Java, how it's related with Julia, how it's related with JavaScript. We would like to know all of this information when we would like to have an answer, right? This is very challenging to have with a simple similarity search and with simple RAG. What do we have to solve this?
Yeah, so one of the tools that you can use to improve the context of your results is adding in knowledge graphs to the picture. And we were a really early adopter of the OPEA framework at Neo4j. We want to find more opportunities to integrate and to leverage technology. And like, excuse me, like Easy was saying, having that platform with different Lego blocks, kind of where you can plug in and integrate, is really, really important. And it allows us to make GraphRAG possible for a whole bunch of additional enterprise use cases. And a really good analogy for this is thinking about it kind of like your brain, where the right side of your brain is great at creation and building things and kind of like that extrapolation that happens with LLMs, which it's very good at. And you can see the type of answers you get. They're very superfluous, kind of wordy, in terms of the responses you get out, and not very specific. Whereas knowledge graphs deal in facts, in specific details. They're very strong at connections. And then you get that sort of precise response with more grounded information, and also connections between different data sources, which we'll show an example of in the demo. And this isn't a new concept. So this is something which Ben Lorica talked about on Gradient Flow very early on about the future of AI is graphical. He's actually been helping out with a lot of the content for different conferences like the AI conference and now a bunch of the Linux Foundation conferences. And really, graphs provide a whole new way of looking at data and exploring data. Microsoft did this kind of the seminal paper, the GraphRAG research paper, Unlocking LLM Discovery and Narrative Private Data. And what they showed is not only can you get more accurate results by using knowledge graphs as part of the process, but actually they also showed that it reduces the token cost. It reduces the cost of getting results back because now you have more specific information. And even, to the extent you believe analysts, Gartner believes 50% of generative AI initiatives will have improved reliability and transparency by combining deep learning foundation models with knowledge graphs. So who here is familiar with knowledge graphs or has used a knowledge graph before? Okay, so just to kind of level set everybody to what is a knowledge graph? Yeah. I think a really good example of this is the Panama Papers, which was a data set which got opened up of 11.5 million documents, emails, scanned documents, bank statements, et cetera. And what you would be looking for in this huge data set, it was 2.6 terabytes of data, was connections which might indicate some sort of fraudulent banking activity. And so the sort of things you'd be looking for is maybe there'd be a person who has an account at a certain bank, right? Then they live at a certain address, so we're already up to 3 joins to get this information. But then they live with somebody else. And that other person is an officer of a company who has a bank account to the Bahamas. So if you were doing this with just a traditional table-oriented database, this would be both a complex query, but then also very difficult to find this small pattern in a very large data set. And what graphs are really good at is they're good at identifying patterns, at connections, related information in extremely large data sets. And you can see here, this is the kind of the large graph. That little tiny colored section is the pattern which we just talked about. And we'd be looking for more of these patterns and things so that we give more intelligence and more context to our artificial intelligence. And I think that the way which we do things with RAG and vector databases is basically using word vectors and statistical similarity. And so that's helpful for models and for machines to process information. It's a good representation when you want to get an initial result, but then it lacks the context where we can actually start to bring some knowledge out of it. So on the right side is your sub-symbolic apple in vector space. On the left side is the same thing in graph space. And that's something we can start to reason about. So, an apple has a body and a stem, which is the structure. It's 10 centimeters large, it's round, it has a red color. And we can start to actually talk about it. And then if you combine these two together, so you create connections between your embeddings and your graph database, then you can start to pull vector searches and then navigate back to the graph for additional context, which is an extremely powerful technique and allows you to deal with some of the challenges with GenAI, such as hallucinations. And I think a good analogy for LLMs is they behave and act a lot like parrots. So they both, learn random sentences from random people, talk like a person, but don't really understand what it's saying. Yeah. Occasionally speak absolute nonsense, usually when we're trying to solve complex business problems.
Oh yeah, totally, yeah. And they talk.
But one of these is not a cute bird.
Yeah.
And so we'd like to make our model smarter and give it more of that domain knowledge, ability to explain answers, reduce hallucinations, and then have the ability to address ethical and bias concerns in the models, because this is a big issue when you're building business applications, that you need reliable, explainable answers which you can trust on. And here's a healthcare business example. So what was the care plan associated with Andrea Jenkins' emphysema? And it compares what you get directly from an LLM. Obviously, there's some baseline knowledge LLMs have just by scraping the web and the internet and their training data set. And it says, preventing further damage to the lungs. This may involve advising the patient to yada, yada, yada. So it's kind of very general, wordy, verbose advice. If you gave it a medical database to a RAG application and you use vector similarity on it, now you get a better answer. Respiratory therapy, specialized deep breathing and coughing, et cetera. So it gives you a better answer, but not something close to what a doctor would prescribe. And GraphRAG, you're essentially passing in the nodes and the relationships directly as context to the LM, and you get something like the final case. So care plan including medication management, smoking cessation counseling, pulmonary rehabilitation exercises. So it's basically pulling back the exact care conditions from a knowledge graph. So that gives you kind of the context of what you would expect from an LM app. This is a general GraphRAG pattern for how you would build a GenAI application. So rather than asking the GenAI application directly to the vector database, you're now asking a graph database where you have both the vector embeddings and you have the nodes in the graph. And now you can search both by vector similarity and graph traversal to get back the results. And this allows you to do a whole bunch of different patterns on the data. Where a lot of people start with GraphRAG is doing something which is basically converting your input text to a graph query. Cypher is the query language for graph databases, pretty similar to GQL, which is the new ISO standard for graph database queries. That is good, and the models are getting better at generating Cypher queries off of text. But it's not perfect, even if you give it the schema for the database. Sometimes it generates an incorrect query, or it won't give you back the results you're looking for. Often it's better to do a vector search with graph context. And essentially what that is you first do a vector search on the text, get back a bunch of embeddings, and then you look at what nodes are associated with those embeddings, and you pull back related nodes either by cosine similarity or by community groupings, which is what they talk about in the Microsoft GraphRAG paper, or other graph algorithms, which would help you to kind of pull out that context. And obviously this extends to things like you can do graph pre or post filtering of your vector embeddings to improve the ordering of results. You can do agent and multi-step lookups. So it adds to a whole bunch of different ways that you can line up the data. And then you can address things like governance of your data and explainability. So like in this case, the customer service agent should have access to the phone number because they're talking to the patient, but not the health diagnosis. Similarly, the doctor should have access to the health diagnosis, but not the patient's personal records. So now you can annotate that in the knowledge graph and then like limit what gets passed into the LM so it can only see the information with the right context and the right access controls. And you can improve the explainability because now the results you're getting from the LM is not just based on vector results coming back from a vector database, but you actually have a knowledge graph that you can point to specific nodes and results that came up as a result of the query. So this gives you better explainability, better context, more accurate results. And a good use case of this in practice is this came out recently where Klarna was featured in TechCrunch. The CEO of Klarna, Sebastian, and he talked about the fact that they were using GraphRAG and LLMs to develop an internal knowledge system that they call Kiki. And this they used to replace thousands of SaaS applications. And basically what they found is that by importing their HR systems, their wiki, their enterprise systems, their internal documentation into a big knowledge graph, they could then do queries against that, and they could pull back insights across the organization, which helped with all sorts of use cases from customer references, support, kind of internal enablement for their employees. And over 250,000 employee questions were answered the first year, 2,000 daily queries, and 85% employee adoption of employees at Klarna using the system. So very successful, and actually help them to get ahead of their competition in a bunch of ways. And OPEA provides a blueprint for doing this inside.
Yes. It was if you would like to use it, OPEA provides the end-to-end blueprint, which is actually uses the GraphRAG, has an LLM and some more components that we don't have time to go specifically deep there, but you have a Docker Compose file that you can download it and you can run in your environment. This is not the best description, but this is actually the architecture that you will have when you download this Compose file, which has an input, an UI, you have a GraphRAG gateway, and you have the mega service, which is actually what is orchestrating everything that is going underneath, how you're doing the retrieving, how you're doing the embeddings, and so on, how it's interacting with the database, with the graph database. And also provides a part to do the data ingestion. So if you would like to ingest the documents, of course, there is a data preparation mechanism. And this is, when we talk about those components, these are the same components that you may use in a regular RAG. of course, what changed is how you actually do the search or how you actually do the ingestion of the documents, which is totally different from a common RAG. So from a perspective, if you have a RAG deployed, you just change some few components and you start using your GraphRAG. Or you can use both, or you can interact both. Or you can put an agent in the middle that can be selecting. I don't know. It can be something very, very crazy. But that's the pluggability that OPEA provides. And we have a demo.
Yeah, so we have a short demo to showcase like what it would actually look like to use a GraphRAG application. And the idea here is we're using a knowledge graph builder demo application, which allows you to import different data sources. To give it some context, here we're adding in a bunch of different Wikipedia articles on different sci-fi series, because as geeks, you always have to start with a good, cool sci-fi reference for your demos and presentations. And so it's importing stuff from Star Wars and Terminator, and a whole bunch of different, like, really common sci-fi series. And what this does is we'll take these in to the graph database. It will parse them and do the embeddings off of this. And then we'll also build up, using named entity extraction, a knowledge graph off of each of these. So this takes and actually does the ingestion of the documents, where it's now part processing and taking the individual documents and converting them into graphs. And this allows you to have a knowledge graph, which is built up off all these different sources and creates connections across them. And what we're going to do next is we're going to look at one of these individual sources and kind of get an idea of what an actual graph would look like for this. So for this example, I think we're going to choose the Terminator to show the knowledge graph. And initially, when you click on it, it shows a graph with all the different entity chunks and the nodes and everything. So we can turn off the chunks to make it a little bit more clear, so that we'll only see the actual extracted entities from the Terminator series. So there, we're removing the documents and the chunks. And then we get a graph which we can start to kind of conceptualize about. So you can see the center is the Terminator. And then extending from that are all the related nodes. Now, since this is a graph which includes all of the different movies, we can also start to see connections between movies. And here we're seeing part of a graph which is coming from Blade Runner. And you're like, well, what does Blade Runner and Terminator have in common? But if you look at the Wikipedia pages, they're actually both referenced and categorized under the general theme of tech noir. And so there's a node there called Tech Noir, which is the connection between those two. And then now we can do a conversation, a chat with an LLM. You can choose your base model of choice that you want to integrate with. And then we're going to ask it basically the same question of, like, what themes do the Terminator and Blade Runner share in common? And then see if it can successfully give us like an accurate and precise answer based off the knowledge graph information and what's there. And you can see after the LLM goes and often thinks for a bit, that it comes back with the response that Blade Runner and Terminator share the theme of tech noir, and both films explore futuristic technical elements, yada, yada, yada. So like a very precise answer that's more specific than if we just asked like ChatGPT in a general knowledge base for this information. You can imagine if you loaded up like industrial information, healthcare information, other knowledge sources, this greatly improves the accuracy, and it reduces hallucinations of what you're getting back from your models.
And the amount of way that I need to ask, double ask, triple ask.
Yeah. And so I think like having the power and the capabilities of GraphRAG combined with OPEA, which gives you a general purpose framework for building this, is extremely powerful and lets you do a whole lot that you're not able to do normally.
And there are a few ways to participate in OPEA. If you are interested, you're a contributor, and you would like to add examples, I'll play a bit more. You can visit the opea.dev. Basically, if you would like to join to our working group, there are multiple working groups. We should have a GraphRAG working group or something related. But there are security working group, DevRel security group, and technical, of course. Or if you like to use it in your company, there are some companies, for instance, that are starting to use this in finance or in healthcare. and they are contributing their ways to do the things or their components. To clean the data in finance is something very different from how you clean the data in another environment. So they are contributing those components. Provide feedback, of course. This is an open source project, right? So the idea is to have multiple people contributing, fixing. We all work with open source, so something it doesn't work. So you can contribute, or you can provide a blueprint. If you are working in a particular industry, you can provide your blueprint, or you can take it and you can modify it and you can contribute it back. If you have some time today at 1:30 in ballroom 3E, which I think is close-ish, we'll have a workshop, which is a tutorial, but it's actually a workshop. If you have laptops, bring your laptops. You'll be deploying the chat Q&A, which is the RAG example. And we'll be talking about, and we'll be showing, I'll say like a lecture, what Stephen showed, but very in deep. It's a 2 hours workshop, so we can go deep, we can answer to the questions, and it's more the idea is to really show you. Yeah, this is today at 1:30. And that's it. So
cool. So thanks so much for joining our talk. We can stay to answer a few questions. I think we
did it on time.
5 minutes.
We did it on time, yeah.
And if you guys don't mind, let's do a quick selfie for the audience.
Yes.
So I'll flip around.
Oh, yeah. Sure. Here.
Okay. And say OPEA. All right. And any questions from the audience? So just raise your hand, shout out. We'll repeat it so everyone can hear it easily. Go ahead. Yeah, okay. So the demo which I showed it's a simple web-based example of this using the Knowledge Graph Builder. And so we have a website set up where you can do exactly what I showed on your own without any coding. So you can import different Wikipedia articles, you can pass it in documents you upload from your computer, and then you can test it with an LLM quickly. Now, all of that's based off an open source repo. And it's built off of our integration with LangChain, with different models, and with OPEA. So you can do that same workflow inside of your application using the open source demos. I'd recommend, if you want to give it a try, come to the workshop this afternoon. Yep. And my colleague, ABK, I'll probably drop in as well. Easy and others will be there and actually like walk through all of this hands-on. Yeah, okay, so good question. Let me repeat it so everyone can hear in the back. So basically the question was, what are the advantages of using GraphRAG, either in token cost or like quality of results or different things, which would make it the investment? Because obviously there's a little bit extra work you have to do on top of a basic RAG approach, which it's super easy to throw documents in a vector database. But then, like, the question is, why would I also layer a graph database on top of it? So there's a few business drivers for this. I'd say the biggest one is improving the accuracy and the ability to explain the results, which are coming back from your application. I've talked to, well, a lot of both our customers, but also people who have RAG applications and are in the middle of implementing GraphRAG. And what they are experiencing is, in their RAG application, they basically hit the threshold of how good they can get the results. And they're not able to get the quality of results they need to expose it to people outside of their company, right? So if you're getting maybe 80% accuracy in terms of the responses back, that's fine if you have a human in the middle to check all the responses, but then you can't give that to an end user. GraphRAG gives you that extra additional accuracy, where now the results coming back are a lot more accurate, a lot more suitable for business purposes and like more technical use cases. Now, there's also benefits for things like token cost and reduction based on how you implement it. In the Microsoft GraphRAG paper, they talk a bit about this for their use case and the token costs of like the RAG baseline versus the GraphRAG implementation. And they saw reduced token usage in their case, but it's based on how you're building the knowledge graph, the sort of queries you're giving it, and then like how many queries you need to get back the response which actually meets the criteria you're trying to hit. But based on your application, you can also see some reduction in token costs. But I don't think that's the primary reason why people choose a GraphRAG architecture. Okay, but excellent question. And we probably have time for one more question before we have to wrap up. Anyone want to have the final? Okay, so I saw 3 hands go up at the same time.
At the same time, so.
We're going to give it to the guy in the center. Okay, go ahead.
Yeah.
Repeat the question.
Yeah. So it was a great question, though. He was talking about the Helm chart, what is available in terms of scaling, what are the hardware options that you have to scale your embeddings, microservice, vector database, or something like that, which is the main goal of OPEA. What you will have, for instance, in your Helm chart is you can set in the Kubernetes, you can set, for instance, horizontal pod scaling or vertical pod scaling, and you can separate that from the different microservices that you will have. The goal of OPEA is to keep it agnostic. So if you are working with AWS, you probably will be relying on some microservices that AWS will provide you, for instance, auto-scaling, load balancer, and all those services within your Kubernetes cluster. You can have those deployments there, and AWS will take care of you. Or if you like to use it in a very open Kubernetes cluster, you can download it, and you can use your own version of scaling on horizontal pod scaling, vertical pod scaling, and all those kind of things. From the OPEA perspective, we'll give you the tools or the template on how you can scalate that, make this scalable. And it will up to the platform that you choose that will give you those tools to make it more scalable or not. Did I answer your question?
Oh, yeah, I guess maybe it's still not, like there's no template for HPAs or anything.
Yeah, if you go, yeah, because in the repo you have GenAI examples, GenAI comms, and GenAI infra. Someone is calling me. GenAI infra. GenAI infra is everything related with scalability and everything related with Kubernetes. So there you will see the Helm charts. There you will see, for instance, Terraform templates for each platform. And all the things related with that is on the GenAI infra repo. Yes, probably we should be doing better. Yes, thank you. Yeah.
Okay, so thanks so much for joining our talk.
Thank you so much.
You can find Easy and me in the LFI AI and Data booth in the sponsor area. So we'll be hanging at the booth and be generally present. And feel free to catch us after the session to ask additional questions. So thank you so much.
Thank you so much.